we're gonna continue, oh, there we go, I turned off the chat and then it showed up. Let's continue where we were. This is math 65, we were in 5.7, looking at rectilinear motion. Maybe it's 5.7b. Suppose a particle moves, we did that problem. Constant acceleration. We looked at velocity, let's look at constant acceleration. So if a particle has constant acceleration a. On or along the s-axis, s-axis. And if the position and velocity at time 0. Are S naught and V naught respectively. We get the following. If you integrate a dt, you get at plus the constant. But that constant is V naught. So that's our velocity function. And if we integrate V naught plus at, we get V naught t plus 1/2 at squared plus a constant. And that constant just so happens to be S naught. And that is S of t. So let's just do an example. Do a couple examples. For intergalactic spacecraft. Well. I don't know that we're going intergalactic yet. Going between galaxies isn't really happening, but this is how it would be, what's something we would need to have working to do. Spacecraft need fuel efficient or need a way to accelerate for cheap. Needs cheap acceleration. And that comes in the form of solar sails. Which get pushed by sunlight. Sunlight and solar winds. So let's say it starts at 0 velocity. But has an acceleration A equals 0.032 meters per second squared. How long until its velocity is 10,000 meters per second? Or 10 kilometers a second? That's fucking fast. That's super fucking fast.
Is that, the first one, is that meters over second squared?
Yes, meters per second, yeah, over second squared. The square is only on the S, not the N. Well, V of T is V naught plus AT. V naught is 0. A is 0.032. T. And we want that to equal 10,000. This side is meters per second squared times T, which T must be in seconds. The right side is in meters per second, so the units balance. So I'm not, we're finding a time in seconds. If you divide that 10,000 by 0.032. We get 312,500 seconds, which sounds like a lot. But if we divide by 60 to turn that into minutes. And divide that by 60 to get to hours. If I divide that by 24, this is only 3.6 days. And in space, nothing's slowing you fucking down. So, but assuming you maintain a constant acceleration, I don't know if the solar cells work out. I think the distance from the sun affects that, but I'm not confident of that. Either way, without anything to slow you down, no friction in space to slow you down, you can start chugging along for free. You don't have fuel you're using. Just look like a giant sailboat. They're kind of neat. They're in use. They're making them. They tend to be small for little ones. Trying them out, but look up solar cells if you're interested in it. How long after 10,000 meters or after 10,000 meters per second is hit? How far will it travel in 1 hour? Well, we're gonna use the position function. S naught was, we'll just assume it's wherever it starts, we don't know where it's starting. But, well, maybe we should integrate this thing here. We'll integrate V naught 8 plus AT. I'm gonna go from 0 to 1 hour, since time is in seconds here. I'm gonna put like the hour in that, what is that? 60 times 60 is 3,600. I need a calculator for that. 3,600 seconds. And we are using B naught plus AT. B naught is now 10,000, we're starting at 10,000. Plus 0.032 T. TT. So we integrate, we get 10,000 T plus. 0.032 T squared over 2. And we're gonna evaluate that from 0 to 3,600. Holy shit. Which is 36,000 kilometers and some change. Approximately 36,000 kilometers. At that point, you're not really giving a shit about the 57 meters. You know what I mean?
Well, we've integrating this, is giving us the area under the velocity time graph, which is position.
Yeah.
Okay.
Yeah, the integrating velocity is giving us the S of T. Good God, that's a lot of kilometers. Alright, so let's bring it down to Earth. Gravity due to acceleration, or acceleration due to gravity. Is obviously downward. Or. Technically more like inward. Since down is relative to where you are on the planet, but it's always inward, no matter where you are on the planet. But. It's denoted G as G for gravity. G is approximately 9.81 meters per second squared. In the metric system. Or 32 feet per second squared. In. Our system. Or the hell our system's called. What?
He hasn't figured it out. Curious.
Yeah. Usually we use. Usually we have. A. Our acceleration equals negative G. Negative for being downward, since we do up is positive, down is negative. So let's say we release a penny. From atop the CN tower, whatever the hell that is. Which is 338 meters above ground. A lot of these tall buildings, like the Empire State Building, have like. Fucking big gas balcony on top for you to walk around and like view. And if you're gonna build something that fucking tall, you might as well have somewhere to. People to look from, right? Assuming a free fall model, like no friction. No air friction or anything. How long until it hits the ground and what speed is it going? I drew a little zero there and the penny is bigger than his head, that's fucking awesome.
Oh, yeah, I heard it hits you.
So let's call ground height 0. So that the top of the tower is the 338. So if that's the case, I would say S naught. Its starting position is 338 meters. And if I just drop the penny, the starting velocity is 0 meters per second. Make sense? So we have S of t equals S naught. Plus V naught t plus 1/2 AT squared. And we're trying to find the time. What is P when we hit the ground? Well, when we hit the ground, S of t equals 0. S is our position function, if we're putting that, setting that to 0. That's what we've got to put in, so we got 0 equals 338 plus 0t. Plus 1/2. We're looking at meters, so I'm gonna use G as 9.81. We got T squared. Let's just go with 9.8 to make this a little bit easier. So that should be 4.9 T squared plus 338 equals 0. Minus. Because the 9.8 is negative. So if I move the 4.9 T squared to the other side, they are now both positive. We divide by 4.9. I'm getting 68.98. If I take the square root of that. T is approximately 8.3 seconds. So it takes a little while for it to fall. Not that long, but. It's not instantaneous.
Do you ever watch Mythbusters? You ever see the penny off the skyscraper episode they did?
Yeah.
Where they tested if you threw a penny off well, they were going off the Empire State. That it could get embedded in concrete if it hit straight down into the
Yeah.
ground. And
I bet it didn't go through the concrete, but I'm sure it will go through someone's head.
oh yeah, I think that's what they ended up testing at some point is would it go through?
Head?
Yeah,
So, what?
well, no, but they use like a gelatin mold.
Volunteered for that.
Right? How much you gotta pay someone to volunteer for that shit?
No.
Alright, so V of t. Is V naught plus AT. Which is 0 plus. A negative 9.81 T. And we're looking for the velocity at 8.3 seconds. So negative 9.81 meters per second. We'll use 9.8 because that's what I used earlier. I rounded there, so we'll round here. And t is in 8.3 seconds. One of the seconds cancels out and we get. What is that, 81.4? Negative 81.4 meters per second. We're saying it's negative because it's going downward. Whereas if it was positive, it'd be like going up into the sky. That's pretty fast.
So David,
2.5 feet or so. So like 250 feet a second. That's cooking. Yeah, that's why.
oh, it's not the same result if you put 9.81. Yeah, I mean it's the same if you put 9.81 or 9.8.
What, fucking throw it in a calculator and figure that out on your own.
Okay.
I know you know how to determine that. It's probably pretty close. 0.01 added to the 9.8 isn't changing it a lot.
Okay.
Alright, so that's it for 5.7.
John, on that one, you just multiplied the 9.8 and the 8.3 together?
Yeah,
Okay.
cause it was A
Oh,
times T.
because, okay, cause you still needed V of T, okay.
Yeah, so we changed what we were doing. In the first half, we were finding T. Here, we were actually using T.
It's how long till it hits the ground and then what speed is it at?
Yeah,
I think I just got thrown off by it saying V of 8.3 seconds. I think that's what was throwing me off, was that was part of the equation, but it's just representing T.
alright. Onward, 5.8. 5.8 is on the average value of a function, and we mentioned stuff related to this before. In fact, we used it in previous sections. As part of our arguments, I don't know why 5.8 is after those, because it was used in it. Remember we were doing the mean value theorem for intervals, and we showed like the top value and the smaller value, and we said there's an average in between. That's what this is. F of t average or f of x average is 1 over b minus a times the integral of a to b f of x dx. When we started the mean value theorem one for intervals, we started with f times b minus a equal the integral. But then you're just dividing by b minus a and you get that. So. Example. This is a really short section because. We're just integrating. Find the average value of the function. F of x equals 2 plus cosine x. Over the interval 0 to 2 pi. And then. Find all values for x. For which. F of x equals the average. many people are online? It's only 7 students in here. That's crazy. 7 online too. Alright, well, let's find our average first. F average is 1 over B minus A. B minus A, that is going on based off the interval or the interval AB. So 1 over 2 pi minus 0 is B minus A. And then we're doing 0 to 2 pi of 2 plus cosine x dx. Alright, so we'll integrate that. We got 1 over 2 pi. We integrate the 2, we get 2x. What do we get when we integrate cosine? Sine. And we're going from x equals 0 to x equals 2 pi. We have 1 over 2 pi. If I stick in 2 pi, I have 2 times 2 pi plus sine of 2 pi. Minus 2 times 0 plus sine of 0. 0 usually eliminates everything, but you can't take that for granted with trig functions. Because cosine or exponentials. Cosine of 0 is 1, e to the 0 is 1. So don't automatically assume that just having a 0 is 0. But in this case, sine of 0 is 0, and so is the 2 times 0. And so is sine of 2 pi. A lot of this shit is 0. Look at that. Almost all of this zeros out. Boom, 0, boom, 0, boom, 0. And I am left with 1 over 2 pi times 4 pi, the 2 pi's cancel, and I'm just left with 2. I'm missing an equal sign here. So we want to know what values of x have this value for f of x. So for part B, we're going to take f of x equals 2 plus cosine x and set it equal to 2, which is at average. Subtract 2, we get cosine x equals 0. And where is cosine x equals 0 on 0 to 2 pi?
Average. It's very average.
Yep. Was that not fun? Super exciting. Let's do one that has, I don't know, a little bit more, I don't know, fun. Suppose the value of a yacht. In dollars. After T years of use. Is V of T, in this case, V is value. 275,000. Fuck that, we're adding another 0. That's not a expensive enough yacht. I still don't even think that's expensive enough, but we'll go with it. $275,000 yacht, that doesn't sound like a yacht, that just sounds like a boat. Jump that up to almost 3 million. That's a yacht. What is the average value? Of the yacht over its first 10 years? And what the hell, what is the value after 10 years? Now, just like we did with the other problem where like part of it was in seconds, but we wanted it after an hour, we gotta make sure we're using the right T. Units for T. Here it said T years of use, so our T should be in terms of years. So that means our interval here is going from 0 to 10. Since that's already in years and the results are in years. If it says some shit like months or days or something like that, we'd have to change those digits. So that's my B and my A, so B minus A is 10. 10 minus 0 is 10. So the average value is gonna be 1/10 of 0 to 10. $2,750,000 e to the negative 0.17 t dt. This is just simple interval. 1/10, positive 1/10, I don't know why I got a okay. And then I got the 2,750,000. And then I'm integrating that. What is the interval of that?
It's still e to the negative 0.17.
It's close.
Is it just positive? Or is it?
Oh, this is gonna segue us into the next thing. E to the T goes to E to the T, but what about E to the negative 0.17 T?
That comes down in front.
That would be taking the derivative.
So
If we-
it's the reciprocal.
Yeah. Let's do this is gonna segue us into 5.9, but let's do a substitution. I'll put a question mark here. Let's say U equals negative 0.17 T. So du equals negative 0.17 dt. And if I divide both sides by negative 0.17. I can see that 1/negative 0.17 du. Equals dt. So if I wanna put u in. There, I gotta change dt to that. So if I did that, I'll rewrite that equation in terms of u here. Oh, but notice this. These are in terms of t as well. So. We have two approaches when you're doing a definite integral and you do a substitution. And you use a U substitution. And I'm okay with either, but you've gotta be very clear which way you're doing it, and I'll show you how to be clear. Option A. Change the limits of integration also. How do we do that? We plug them into the U sub. So when t equals 0. U equals negative 0.17. Times 0, which is just 0. And when t equals 10. U equals negative 0.17 times 10, which is negative 1.7. And if we take this approach. Our integral becomes, we got the 1/10. This is now 0 to negative 1.7. I'm gonna just say 2.75 mil. So writing all those zeros. Then we have the e to the u. And the dt turns into 1 over negative 0.17 du. So here I replace the t, this was my dt. And that was my negative 0.17 t. And the cost of making the swap was changing the lines. The other option is. Leave the limits the same. But indicate what variable they are. And after integrating, you have to substitute back. So if I were to do that here. I would have 1/10. I would say t equals 0 to t equals 10. 2.75 million. I still got my e to the u. And my negative, or 1 over negative 0.17 du. We're gonna work out both of them. I'm gonna show you the same value. And then we're gonna go back up here and reason out what we could have done without doing the U substitution. So we did the U sub with the integrals before, but they weren't definite. And the change is what dealing with the limits of integration. So if we did option A. We've got 1/10, 0 to negative 1.7. I've got. I'll put in the full value here now. And I'm gonna put that negative 0.17 from the du with it. And then I have e to the u du. And we can move that number out front. Move the 2,750,000 over negative 0.17 out front, cause it's just a constant. 0 to negative 1.7 e to the u du. And I don't wanna write that whole big number segment again, so I'm gonna figure out what that is. Oops. That's the first value there, we still got the interval here. You have the option. You can. Change that order. And put the negative 1.7 on the bottom. And 0 on top, so that it's going from lowest on bottom to the highest on the mount, if you put a negative out front with it. Which would make this positive, but you don't have to, and I'm not going to. I'm just gonna leave it alone, I'm gonna integrate. And we get e to the u evaluated from 0 to negative 1.7. I'll do that part in the parentheses real quick. This part right here is negative 0.817316. I'm writing down all the decimals because I got a big number out front too, so like I need a lot of decimals here. And when I multiply those together. I've done some rounding here, so I'm gonna say approximately. 1,322,129. That's the average value of the There are some pennies on it, but like, since I rounded, I don't know how accurate that is, and let's face it, when we're talking about $1.3 million. Who gives a fuck about the pence? Right? Rich people don't care what food costs. Right? Alright, let's do it the other way with the method B. Notice B still has. The negative 0.1, it's got this. The 2.75, the negative 0.17 on bottom, and then 1/10 on bottom. So why don't we fast forward to that, having that value up front on B? Just having negative 1,617,647. We have our integral t equals 0, make sure you got the t in there. To t equals 10. E to the u du. That's really the only difference in these two methods. So we integrate, and of course we get e to the u. From t equals 0 to t equals 10. And now you have to switch back to t. T or u was up here, u was negative 0.17 t. So we're gonna put that back in. And now that they're both T's, I don't really need to say the T anymore, now that I switch back. But I did. And if you do this. We have e to the negative 1.7. Minus e to the 0 again. Which is what we had up there. So we're gonna get the same answer.
Or a method you prefer, you think's easier to go along? Easier to remember?
That is an excellent question. I think they both have something you have to remember that you need to do. And then at that point it becomes, my honest assessment here is. How much of it is a pain in the ass to switch over the limits of integration? Plugging in 0, like we had. U equals negative 0.17 T. And we were doing T equals 0 and T equals 10. This was not hard. I didn't need a calculator for this. If I end up doing something and I get something where I'm rounding. Where I have really weird limits and all of a sudden there's like, I'm having to round because it's unending on the calculator. I won't change limits. So if I can change limits. Easily. And without rounding. I think that's the better path. For one simple reason. If you don't, you have to remember to switch back. You have to make sure you put these T's. In up here, you gotta put the T's in here. And as soon as you stop doing that, you're wrong. And it's easy, like if I don't have these T's here, if I just have 0 to 10 here. All it takes is a text message, a car alarm to go off. You get distracted for a second, you look down, you look away, you look back. And you start plugging in 0 to 10 right here for you. Rather than what you needed, which would have been if we had it in U, negative 0 and negative 1.7. So like. That's the problem with having to switch back. It's easy to get distracted, or even if you're not distracted, if the problem was, if it was a long thing to integrate here, not just e to the u. It's easy to forget that you had to go back. It's easy to forget to write down t equals, or whatever the variable is. It's easy to forget that. So if you can, without rounding and without too much work, you're better off. Less likely to make an error, and let's go with. Changing the limits of integration. I got a whole lot more problems with this, but it's been an hour, let me give you guys time and break. And we'll go over the official definition of how this shit works. Alright, let's get to the fanciness of 5.9. So we did a little intro to it, but 5.9 is on. Evaluating definite intervals with substitution. So if G prime is continuous. Continuous on. Our interval AB. And F is continuous. on the range of GX equals U. This is the formal definition for it. A to B f of g of x times g prime of x dx equals g of A to g of B f of u du. I think mathematicians decided on a new set just so they could say fu. Just have it in there. Those are two random letters to fucking pick. Notice that the change in the limits over here from A to G of A and B to G of B. What's going on here is we're saying U equals G of X. So du equals G prime of X dx. And then we do our limit change when x equals b, u equals g of b. And when x equals a, u equals g of a. And this is our u right here. This is our du right here. And these replace our limits. And that's where we get the f of u du and our change in limits. So sometimes you have what you need in terms of a constant. Like if g prime of x is just a constant, sometimes you have it. Sometimes you gotta move stuff over from, like we did in the last problem where we divided by the negative 0.17. We had to substitute it in that way because we didn't have what we were looking for. Sometimes you have it. Let's look at a couple examples here. We'll do the integral from 0 to 7. The square root of 4 plus 3x dx. I'm gonna rewrite that using an exponent. The square roots are easy to forget what you do with them, but when you see them as a power, it's easier to remember how you deal with them. So we don't have a method for integrating 4 plus 3x. So what we're gonna do is we're gonna make a substitution of u equaling 4 plus 3x. Du ends up being 3dx. At this point, stop. Check to see if you have a 3 in there. To go with the dx. If you do, you're good. You just make the substitution and grab it and cancel out. It also always works. It always works to get dx by itself by dividing by 3 or multiplying by the reciprocal. This also always works. Having said that, I've got my substitution change. I'm gonna be having u to the 1/2. And then I've got 1/3 du. The only thing I haven't done yet is change my limits of integration. When x equals 7, u equals 4 plus 3 times 7 is 25. When x equals 0, u equals 4 plus 3 times 0 is 4. Well, I can move the 1/3 out front. And if I integrate. I go up a power. And divide by the power or multiply by the reciprocal. And I'm going from 4 to 25. So I have 2/9. U to the 3/2 is the same as u square root of u. So I have 25 times the square root of 25 minus 4 times the square root of 4. Which is 2/9. 25 times 5 is 125. Minus 4 times 2 is 8. That 117 on the inside. Which is evenly divisible by 9. If you add up the digits. And it's divisible by 9. Then the number is divisible by 9. I don't know what 117 divided by 9 is. But I know it's divisible. It's 23. 13, oh shit, I gotta put it to that, yeah, 13. So this would be 2 times 13 is 26. That's like doing a little bit better. Showing why it's canceling, so the final answer is 26. If you put it all in the calculator, it should have just shown 26 anyways, but. Try to avoid the calculator as much as possible. The less you rely on the technology, the more you're making your brain work, better the shit sticks. And the quicker you're able to do math in the long run. Every time you have to slow down and stop to use a calculator, that's literally seconds off your life. And it may not seem much. But if you're going into a field where you're making calculations a lot. Seconds turn into minutes, turn into hours, you're losing days. Wasting time on stuff that you could just spend quicker with your brain. The other way of going about doing that one. Is we could have had the u to the 1/2. 1/3 du. And I could have said t equals 0 to t equals 7. Option B. You ended up getting the same thing here. 2/9 u to the 3/2. From t equals 0 to t equals 7. Which is 2/9. 4 plus 3x. To the 3/2. From 0 to 7, now I don't need the t. And you'll see when you plug those in. You get 25 to the 3/2 minus 4 to the 3/2. Which is the same thing we had up above, I just wrote in square root notation. And you'll get 26 here also. My perspective as a teacher grading this shit. I can tell you honestly that students that don't transition or make the change on these limits. Half the time fuck up and forget later on, do something wrong later on. Don't indicate that they didn't change the thing, like don't put the T here. Or X, that should have been X. The original letter was not T, it was X. So they lose points because they didn't make the change. So if you're wanting to avoid losing points, getting a higher score. Take option A. You notice these calculations still had to be done. The 4 plus 3 times 7. I'm just waiting to do it here now. The 4 plus 3 times 0 I did here, I have to do here now. You eventually have to do those calculations. You're not saving yourself any work by waiting till later to do it. So it's better off to make the change if you can. If you don't have any like rounding shit going on, it's worth making the change. Does that make sense?
Not in decimals and stuff like that.
Yeah, and like if you end up rounding, you're gonna get the answer wrong. And we're looking for an exact answer and it's fucking. 2.9785 and you just give me 2.97, you're wrong. It had an exact answer, you rounded too earlier. You guys ready for another one? Integral from 1 to 2, 2x e to the x squared dx. What works here?
So
On what?
on x squared.
Like I know it's a you said, that's what this chapter's on. Try to trick me. So if I take the derivative, what do I have?
X squared dx.
I do not have x squared dx.
Or 2x dx.
Alright, go and look to see if you have those parts. I do. This is my du. So when I do my integral, I'm just gonna be able to go to e to the u du. The only thing we need to do before then is change the limits of integration. When x equals 2, u equals 2 squared, which is 4. When x equals 1, u equals 1 squared, which is 1.
It's the x that's in the u that we're putting the limits into.
Yes,
Okay, so I looked and thought we did it in the 2 times x.
no, you're making it, plugging them into u.
Yeah.
And now this problem just became simple. E to the u evaluated from 1 to 4 is just e to the 4th minus e to the 1st. Boom, that's an exact answer. Don't fucking calculate this shit, don't give me a decimal. The only time you need to like doing a decimal approximation generally is if it's prompted for. like on the test. Or if you know you're doing something in real life, or like it's a word problem where like this is a meaningless answer. Like if I try to tell you I went e to the 4 minus e to the 1 miles on my way to school today. But just get up, walk over and just slap the shit out of me for being an idiot. Cause that is stupid, right? And I would have had it coming. But unless you don't need to make a change, don't, cause you lose accuracy. Start rounding. Alright, next problem. Oh. We're going to do the interval from 1 to 2, 4x plus 12 in the numerator. Denominator is x squared plus 6x plus 1 squared. That's the denominator, and then we have our dx. Any ideas?
You said the expert, 6x was 1.
When in question, do this shit in the denominator, give that a try. The denominator is always, well, not always, but usually what fucks it up. And don't bother doing the outer exponent, just do that. If I take the derivative, what do I get?
2x6
I have 2x plus 6
dx.
dx. Notice I have the 2x plus 6 in parentheses, because it's all times the dx. I don't have 2x plus 6 in the problem though to get rid of, do I?
But you do have a 4x plus 12.
Well, what can I do with that, Jacob?
If we would have had. Or
Half it or factor out a 2, let's do that. Cause we can't just make it randomly go in half, but I could pull a 2 out.
or
And now I have what I'm looking for. There's my du. If I do that, let's take advantage of our u and make our substitutions here. When x equals 2, u equals 2 squared plus 6 times 2 plus 1. 4 plus 12 is 16 plus 1 is 17. When x equals 1, u equals 1 squared plus 6 times 1 plus 1. It's like 8. So my interval changes from 1 to 2 all the way up to 8 to 17. I have my old 2 there, this 2 didn't go anywhere, that 2 is still there. This is now a u squared on bottom. And we have a du. Now what? Ah,
we can say that the u squared, we can turn that into a u negative 2.
that is how I would do it.
So we have a fraction.
And now when I integrate, I got the 2. I go up a power, what is up a power on this?
Negative.
-1. We divide by -1 and we're going from 8 to 17. At this point, it's easier to rewrite that as -2 over u from 8 to 17. We have negative and then 2/17 minus 2/8. Ends up being, you gotta distribute the negative to both. 2/8 simplifies to 1/4. And 2/17 doesn't simplify. We could find a decimal answer if we needed it, but just leave it like that. That's what I'm gonna leave it on my test, that's what I'm gonna look for. If you try to make me grab a calculator, I'm gonna be irritated. You don't want me irritated when I'm grading. Right? Don't overcomplicate it. I know inevitably someone's gonna give me a decimal answer for this shit. Probably Jacob. You guys ready for more? We're still writing, I wanna pull it too soon. Let me give you guys the next one so you guys can start that, for those that aren't writing this one. We're going from 0 to 1, we have the quantity x plus 1, and then x squared plus 2x to the 5th power. Go ahead, give it a try, see what you come up with. We got this problem and one more problem, so. We do about 10 minutes on each, I'll give you 5 minutes to do it, then we'll do 5 minutes together. We'll do the next one. If we're still going, let's give everyone a little bit longer. You stuck, Anthony, or you just? Yeah, that look, I'm still looking at it. That's a good idea when you're taking a test. If you get done early. This is good for any class where you've made calculations and shit. Fuck, any class, if you've got time left over. before you turn in the test, just got to put your head down or something, like. Listen to like hum your, not out loud, but like in your head, look. Go to the lyrics of your favorite song, you know, purge your brain of what like you've been thinking about. Take 5 minutes, then go back and look over your test. And maybe look over it in reverse order or a different order than the way you did the problem, don't go like start at the beginning and go forward. Go backwards. You might find stupid shit, like 4 minus 1 is 2. You'd be like, what the, why did I, it's so easy to happen. You know arithmetic so well that you. Start thinking about the next part before you finish writing down what you needed to write. And you start writing, you see me do it all the time. Teachers make mistakes all the time in class. It's because we're already going on, because that shit's trivial in how easy it is. Everybody another minute, we'll do it together. What is the final answer? I have no idea. Who got an answer?
I got 16 and 3/4.
16 3/4?
Or 3 to 5.
Okay, anyone else get that?
I didn't simplify mine all the way down, but I have 1/12 times 3 to the 6.
That isn't that fucking helpful.
Oh, yeah, that's the same thing.
Okay,
Okay,
I didn't put mine into the calculator.
okay.
I only had a PC off chums.
I like start rambling off different shit. I'm like, Jesus. Come on, Jacob, get your shit together. Alright, who wants to help me with this? I don't know what I'm doing. Jacob, walk me through this.
I used the x squared plus 2x.
Okay,
And then my du I got was 2x plus 2 ddx, but I factored out a 2. And then divided
so
both
if I
sides.
factor out the 2, I have that.
Yeah, and then I divided both sides by 2. So then I have a half du equals x plus 1 dx.
Okay? Now,
And then I then before I forgot, I did I plugged in my x equals 1 and x equals 0 into my USO.
what'd you get?
For 1, it became 3 and 0 stayed 0.
Alright, so what's my new interval look like?
I wrote it out as half before the integral and then 0/3 or 0 to 3. And then u to the 5th du.
Okay, let's pause. Everyone get the same thing? So he used this for his du. 1/2 du. And he just moved the 1/2 out front. Looks legit to me. Alright, keep going, Jake. Take me home on this.
I went and did the integral. And so I ended up getting 1/2 times 1/6 or 1/6 u to the 6th. And then 0 to 3. And plugged it in. Had 1/12 times 3 to the 6th minus 1/12 times 0 to the 6th, which is just cancels because it's 0.
Okay, so 2 ways you can go about doing this. Jacob said he did 1/12 3 to the 6th minus 1/12 0 to the 6th. Notice that if I factor out the 1/12, you have this. When you've got weird shit you gotta divide by and it's on all of it, wait till the last step to do that. Save yourself some fucking pain in the ass calculator work. Do that shit only once. That's my pro tip on that. In this case, one of them was 0, so like it went straight to it, but. This works anytime you've got a constant, you can always do the constant last. Alright, so 112. Times 3 to the 6th. Is like 1/4 times 3 to the 5th. 3, 9, 27, 81, 243. Over 4. Like that, in my head. Yeah, I didn't get a grab no calculator. It takes practice to get used to it. And like doing 81 times 3. Is work in your head, but after you've seen it enough times, you start remembering what that shit is. Alright. Well. Since you guys. Are doing well on this, good job, Jacob. Now let's see if you can do that on a test.
Oh, dude, I didn't say. I'll be able to do it.
Confidence.
That's right. Fucking day out of a test, fucking you look yourself in the mirror, whether it's in your car or at home before you leave. Fucking pump yourself up. I'm gonna fucking kick this test ass. Walking confident, not self-doubting. Fucking does wonders. Ugh. What's going on here? What kind of bullshit is this? Make sure everyone's on the same page. What's the good choice for the use up here?
Sine of 2x.
Yeah, go with that. I'll let you run with it for a little while before we get together. Anybody following politics? Anyone notice everybody Trump is picking for his new positions of power are all people that are like known in media and shit? There's Dr. Oz for fucking Medicare and Medicaid, there's obviously Elon Musk, but then he's got a WWE fucking boss for Department of Education. You pick a congressman for attorney general who has no degree in law. But he's been in the media a lot for all the wrong reasons.
Think he's playing the power game.
I don't know what the fuck he's doing. But if you're trying to break up the establishment, that's how you do it. Trying to change shit up, get politicians out of politics. You stop putting them in the positions. We'll see what happens. Motherfucker, my coat's been on inside out this whole goddamn time.
We're not judging guns. We didn't. notice.
Probably didn't even notice. Gray on the inside, gray on the outside, I just noticed because the fucking writing is all. Alright,
Obviously, we're still warm.
right? I would have noticed if I tried to zip it up. Yeah. Alright, we got 5 minutes left. Wanna do this one too, Jacob? Wanna show me that you know this shit?
Try. I think once I got close to the end, I started the second guess part of it, but I think I have the first part down. So,
This next step is the one I'm wondering if you fucked up.
okay,
The rest of it's easy after this.
okay, so sine of two x is our u. The u is cosine of two x dx. And then I
That is not it.
If I can.
What's wrong with that? Did anyone get something different for their DU?
Is
Good.
it 2 cosine 2x dx?
It is 2 cosine 2x dx. Chain rule, baby. I was wondering if the chain rule was gonna catch you guys. But it doesn't erase a whole lot. All it does is, once you divide by the 2, you just have a 1/2 du. And you put a 1/2 out front of what you were doing. So let's make our substitutions. Sine, that is pi over 4, which is √2 over 2. Zero. So if I put a 1/2 du in, I put the 1/2 out front. And we're going from 0 to √2 over 2. My cosine 2 dx, that's my du, looks like I got a u to the 5th here. Du. And what I was giggling to myself about a second ago is after we integrate. We have 1/12 u to the 6th again, like we did in the last problem. That's 0 to √2 over 2. Now, if you didn't have the 1/2, you would have had 1/6 there, but. So this is gonna be 2 to the 6th power and root 2 to the 6th power on top. Minus a 0, of course. And rather than grabbing a calculator yet, that's 2 cubed over 2 to the 6th. Which is 1/12 over times 1/2 cubed. Which is 1/8. 1/96. Bam. Now, if the only thing you missed on doing this is that 1/2, you will lose points. The chain rule is part of the tricky shit on this problem. But you're not, if you've done most of it, you'll get most of the points. Like if you would have ended up having 1/192 if you didn't do the 1/2.
No, it would have been 1/48.
Yeah, 1/48. If you had 1/48 rather than 1/96, you would have lost some points, but not like a lot of points, not a little amount, but not game breaking. It's not like making an arithmetic error, it's definitely, that's a calculus mistake, so you get penalized for it. Other than that. That's all we got for lecture. There is no new fucking content. If you want to see, if you see the syllabus, it says 1.4. I can load a video that I did before with it. It is called the Delta Epsilon proof. It is tedious. If you're gonna be a pure math major. You should look at that section and watch that video, but if you're not gonna be a pure math major, the Delta Epsilon proof isn't all that important.
Like just majoring in math?
Yeah, I would say if you're majoring in math, I don't know that it's really all that helpful in other things. But other than that, that's the new content. I will have a practice test up by tomorrow, hopefully tonight. And we will go over it on Tuesday. If you're not here on Tuesday, I will see you for the test after Tuesday, because next week is Thanksgiving.
December 5th, so it's the first Tuesday when we come back.
It's the first Tuesday when we come back, and then let me put up the syllabus screen real quick.
So did we,
So we're gonna do the group practice test on Tuesday. You got Thanksgiving next week, Wednesday, Thursday, Friday. You have classes on Wednesday, you're not show up for that. We'll do the real test for this chapter on 3rd. Another group practice test for the final on the 5th, and then we'll do our final the following week. The following week on finals week, you do not need to come on Tuesday. It's finals week, you'll likely have other stuff, so I will see you hopefully next Tuesday. Get the fuck out.
CJ.
Jeff, I think on this on Canvas is the homework due the 5th? I think it says due on the 5th for chapter 5.
I'll check it.
Okay.
What's up, Josue?
I have a question, like, it is 1/12. U rise to the power of 6. I mean, is always rise to the power of 6?
No, it's because we were integrating u to the 5th.
You can show me.
Nice.
So u to the 5th is going. You go up a power,
Senator Jones.
so u to the
Oh.
5th, yeah, u to the 5th will always go to the u to the 6th. But like u to the 4th. Goes to u to the 4 plus 1, which is u to the 5th. It's the power rule,
Okay,
okay?
okay, on this one is how it works, right?
That's how it is on this one, yeah.
Oh, okay, yeah, because on the other one is -1. Yeah. Okay, I got it now.
Okay?
Thank you.
John,